Okay, so hi everybody. As Chris mentioned, I'm a senior software developer at TRS Systems. I've been working with TRS Systems for the past 3 years and have been involved in application development for a wide range of projects related to hydraulics, agriculture, and IoT integration. Before we jump into the topic of using AI to code with CODESYS, I want to introduce TRS Systems. TRS Systems is a Canadian company mainly providing custom control system solutions and cloud-based IoT solutions. TRS Systems is CODESYS system partner in Canada. And here's a short introductory video. I'm just going to reshare this with sound. So here we go.
Are you a custom equipment manufacturer looking to integrate IoT-based remote monitoring to your equipment? Or does your equipment use Canvas or J1939-based control system that could benefit from cloud-enabled remote monitoring and predictive maintenance? If yes, then we have got you covered. At TRS Systems, we understand that your business is different. And to collect the right data and turn it into profit, you need IoT solutions tailored to your business model. With our custom IoT cloud solutions, we can provide you with a dedicated cloud platform for your unique IoT needs and help your business achieve digital transformation. We can help you achieve one or all the IoT use cases that apply to your business. So whether you're a custom equipment manufacturer, a systems integrator, or your business relies on parts or maintenance of an industrial plant, we've got your IoT digital transformation covered. Contact us today to launch your business into cloud. Stay tuned to find out about our comprehensive 4-step IoT digital transformation process.
Okay, so hopefully the sound was okay for that, but it was just demonstrating some of the IoT solutions that we provide. One of the services we provide is advanced control system integration and all the things that go along with that, such as wire harness design and the programming of the PLCs and ECUs. Another service is industrial Internet of Things, which normally we leverage ImmerCloud, which is a custom dashboard for viewing and analyzing data. And on top of that, we also do basic and advanced CODESYS training. Some of our use cases are listed here. Control systems for mobile industrial equipment like agriculture feed mixers, tractors, and cement trucks. Asset management using cloud connectivity, and this is really good for keeping track of remote assets and predictive maintenance as well. Here are some of the companies we've worked with while utilizing CODESYS. Usually when working with these companies, it's on their own custom hardware. So we're experienced with many different kinds of PLCs and ECUs, and working with so many has kind of given us a pretty broad view of this hardware space. All right. So now that I have the introduction taken care of, we can talk about using AI to code with CODESYS and basically how to automate object-oriented programming in CODESYS. So TRS Systems has developed a tool leveraging natural language AI technology to improve our internal workflow. New features are rapidly being developed for this tool and in the AI space in general. But as I'll demonstrate, this technology is already delivering value in the CODESYS environment, and it has some very interesting use cases, which I'll talk about. So what do I mean by AI? So AI is not a very concise term. Specifically, we are using large language models, or LLMs for short. Here's a list of some of the most state-of-the-art LLMs. You have OpenAI's GPT-4, which powers their ChatGPT-4. Google's Palm 2, which powers their Bard chatbot, and Meta's Llama 2. These are all the state-of-the-art ones, but new models are coming out all the time that can even be run locally on a GPU instead of on a server. Most people have probably interacted with LLMs through apps such as ChatGPT and GitHub Copilot. But throughout this talk, I'm going to kind of separate the LLMs from the apps, because it's definitely useful to understand the LLMs by themselves, because it can it can make it more clear how it can benefit your own unique workflow. I like to think of these LLMs kind of as a conversational autocomplete. So this is a screenshot of one of the user interfaces we've made for this tool. It's the chat interface. So at its simplest, it can automate many of the more tedious aspects of programming. And using this tool has turned out to be a net positive for TRS systems, benefiting programmers, managers, and customers. So in this screenshot, you can see it focusing on a function block. I'm not using exact language. I'm saying focus on FF02 encoder, and it's focusing on a J1939 function block encoder. Then I'm telling it to edit the code so that it follows the attached CSV decoding schema. And I'll go into more detail on this in a bit. So in this presentation, we will cover the topics below here. So I'm going to talk about how we integrate this tool within the CODESYS development environment. I'm going to give an introduction to LLMs. I'm going to demo the use cases. Then I'm going to talk about the benefits that TRS Systems has experienced with this way of doing things. And I'll give some feasibility and options that maybe you can consider for your organization. I'm going to try to explain and demo the basics of using LLMs in CODESYS. And I hope it's going to give you enough information so that you can decide whether or not you think it can fit into your own personal workflow or your organization's workflow. And of course, we want you to reach out to TRS Systems if you think you can benefit from a system like this, or if you have any questions related to using LLMs in your CODESYS workflow. Okay. So right off the bat, we'll get to a couple basic examples. The first example I'm going to show you is creating a POU using natural language. And the second example is going to be calling a function block within another POU with natural language. These examples are from more of the early research we were doing with LLMs, but they make good demos because it kind of shows you the LLM's utility, and it helps gain a bit of trust and that they can actually do useful things. Okay. So first off, I'm just focusing on this PRG folders that I've created. That's just part of the this type of GUI, so it's not that important. But I'm saying create a PRG to control the conveyor in section 55. So I'm using pretty informal language, and the LLM has said I have created a program called PRG conveyor control in section 55. And I'm just going to pause it here for a sec. Some things I want to point out about this is I'm using quite informal language when I'm talking to this. I'm not capitalizing. I'm just very kind of off the cuff telling it what to do. And the way I've set up the prompts and stuff, it accurately names the PRG. So I've set it up that I've told the LLM that I want my my POUs with separated by underscores with capital letters starting each word, and I also want a bit of Hungarian notation. So I want the PRG to be prefixed to the program name, and you can see that it successfully does this. And it also brings the small description that I've given. It does add that documentation to the top of the program, and that's pretty essential if you're going to be using this type of thing. So I give it another example here. I say create a PRG to control the sprinklers in the East Garden. This PRG will control the water and fertilizer volume. Okay, so let's continue this. So again, you can see that it's successfully, this time it adds even more detail in the documentation section, in the comments about the PRG. And again, it accurately, or it names the PRG what I want. So yeah, that demonstrates a couple things that these LLMs can do, and this is kind of where TRS Systems we started gaining a bit more trust with using these LLMs, and we decided to continue testing and exploring what these can do. So in the next example, here we go. In the next example, I'm calling a function block within another PRG. So at the top of in the CODESYS there, you see I have a function block called single coil, FB single coil. Basically, it's controlling a coil that has a jump to current and a max current. And then in this example, it has some PID constants that you can feed it. This is kind of, it's missing a feedback, but this is just for example, for kind of demonstration's sake. And what I'm going to do is use natural language to call this single coil within the PRG auger that you see down below. So I will start this. Okay, so first I say call the single coil. Jump to current set to 450 milliamps, and the max current is 1.1 amps. It comes back to me and it says, sure, I can help with that. However, I need some additional information. Can you please provide the values for the proportional, integral, and derivative constants in the PWM PID loop? I say, I want to set the I constant to 5, and the other PID constants can be set to 0. And I'm also kind of editing my previous statement. I'm saying, oh yeah, and change the jump to current to 0.5 amp. Again, I'm using very informal language with this, but it actually does a good job, and it accurately calls this this single coil function block in the PRG. So you see the jump to current. I say I want it to be set to 0.5 amp. The LLM accurately changes that 0.5 amp to 500 milliamps, 500 milliamps, and the max current I said was 1.1 amps, and it accurately changes it to 1100 milliamps. So again, these are some more basic examples, and there's some more interesting examples coming up, but I think it demonstrates a few good things about these LLMs, such as it can ask these follow-up questions if it doesn't have enough information, and it can accurately infer the meaning of what you're talking about and convert it into the proper units. So we integrate with CODESYS using IronPython. If you haven't looked at IronPython usage with CODESYS, I suggest you do. It's very useful. There's a ton of use cases. I put the URL here so that you can check that out. I'm going to go through a few of the use cases just so that you have a general idea of what IronPython can do. And of course, another option for integrating this tool into CODESYS would be the automation platform, and that would give you even more freedom to interact with the CODESYS IDE. And kind of just referencing one of the tech talks from yesterday, CODESYS Go is expected to support add-ons similar to Visual Studio Code. So in the future, that would probably be another way to leverage LLMs with CODESYS. And TRS Systems is going to keep up to date with that. So this is, like I said, one of the user interfaces we've made. For this demo, we decided to go with your chat style user interface, and this is using IronPython's .NET bindings. So basically, one of the big things about IronPython is there are bindings to the .NET framework, which means you can create you have a lot of freedom to create your own graphical user interfaces. And mainly what our tool does is interact with the declaration area and the implementation area of any structured text POUs or DUTs. And I just have it demonstrated here or shown here because I didn't know that this was called the declaration area and this was called the implementation area, but through using IronPython, you end up learning more about the CODESYS environment. So you could have just as easily made a button on the toolbar. Instead, if you didn't want a chat interface, you could just as easily tie specific functionalities of these LLMs to the toolbar and use a more traditional graphical user interface. They would all arrive at the same endpoint, but again, for this demo, we just went with the chat interface. So I recommend, if you're interested in IronPython, I recommend reading this section of the CODESYS IronPython documentation. It does a really good job of giving examples of how you can interact with CODESYS using IronPython. Like one of the first examples in that section is print out your device tree. So basically you can get a list of IronPython objects that you can interact with using IronPython. You can also read variables while logged into a running device. There's lots of applications here. You could make scripts to make sure everything's running correctly on any of your devices. another example here is creating and editing POUs, which we use extensively with our tool. CODESYS also provides some prefab user interfaces that don't require you to dive into the .NET side of IronPython. That can be very helpful as well. And there's a few other use cases as well that are useful. You can edit project information, import and export POUs or devices in CODESYS native XML or in PLC open XML formats. You can automate code and library installations from SVNs, and you can call these scripts from the console without even opening CODESYS. So do check that out if you haven't already. And I think I wanted to explain it because it gives you a bit of background about how we're interacting with CODESYS. Okay, so before I show more examples, I want to talk about LLMs and how they work. LLMs are neural networks that have been trained, from my understanding, mostly on textbooks and a large chunk of the internet. Well, this is the case for OpenAI's GPT-4, and I suspect Llama 2 and Palm 2 do similar things. How these LLMs work are basically you supply it with text, and it iteratively replies with the most probable next token. So there's no guarantees that what it's going to reply with is going to be correct. But it turns out that it's been trained on so much data that it actually is correct a lot of the time, but you definitely can't trust it per se. And I'm saying this just because I want to get everybody's expectations kind of on the same page, because I mean, LLMs have been in the news for so long and kind of memed on the internet so much that you kind of don't know what they're actually supposed to be doing. So you can see from this little flow chart here that LLMs take the text, they break it up into tokens, which is usually 1 or 2 letter chunks. And then these tokens are changed to embeddings, which are kind of like mathematical coordinates of what a word means. And also inside that embedding, it kind of includes its position in the sentence. And then the LLM replies with the most probable next token. I'm gonna put forward a metaphor to call it like a transistor, and take it with a grain of salt, this metaphor, because it might not be 100% true, but what I'm trying to convey is that it's less of a monolithic AI, and it's more of a tool that you can use iteratively with itself to kind of get what you want out of it. So I say LLMs, just like a transistor, for example, act differently depending on how you bias it. So there's a couple ways to do that, and I'll get into them. And transistors are only really useful with a framework around them. So I would say the same thing applies to LLMs. Interacting with the LLMs and getting them to do what you want is kind of half the battle. And the other half is creating a framework that they can operate in and actually do things. One of the more recent kind of ideas that's going around is you can use many of these LLMs together, and they call it something like the Society of Minds, where you get a few LLMs that are specialized in doing different things, and they kind of check each other's work, and it results in more accurate results. Now, that's a bit out of the context of CODESYS, but I do want to put forward that I want to separate these LLMs from the apps that you might be familiar using them. So just continuing on that idea, how does ChatGPT differ from GPT-4 API? Well, ChatGPT uses the GPT-4 API, but it does a whole bunch of other things as well. Like it manages your conversation and it manages your account. So every time you interact with the GPT-4 API, you have to send it the entire conversation, and the GPT-4 API doesn't really have a memory. You have to manage your conversational memory aside from the API. So, and that's exactly what ChatGPT does. But I just wanted to highlight that. Here is basically how you interact with these LLMs. This is specifically for GPT-4, but this is kind of across the board how you would interact with these LLMs. So on the right, you see I have an example conversation. There's 3 roles that I can take. There's system, user, and assistant. So the system message is kind of telling the LLM how you want it to behave in this conversation. So you see here, I say, you must write only in IEC 61131-3 compliant structured text. So now the LLM should only reply to me in code instead of prefacing that code with kind of a preamble or something like that. Like with this application, I don't want the preambles. We just want the code to be returned. So then the next message is from the user role, and I say write a function that returns the sum of 2 numbers. The next message is an assistant message that I've created. And the reason you do this is because if you give the LLM some context and some kind of history, it's probably going to reply in the same way that it has earlier in the conversation. So if I want it to reply in a certain way, I would put it kind of as this assistant message, and then it would increase the chance that it's going to reply with that kind of style. So with this next user message, I say write a function that returns the sum of 3 numbers. It should put a comment first, and then it would say output equals input 1 plus input 2 plus input 3. So the other way to interact with these LLMs is this function call functionality. Basically, you give it a JSON schema of your function arguments, and then it can infer from a block of text that you provide it. It will take what it thinks best fits into your function arguments. So in this example, I have this jump to current, and the description is the jump to current for the coil represents the bottom of the current range measured in milliamps. So just to kind of throw it back to the example where I called the single coil POU in the auger PRG, it was able to change the amps, the unit that I gave it. I said jump to current is going to be 0.5 amp. This is where it kind of, you can tell the LLM to change it to milliamps. And it's what you put in this description is going to influence how it parses your the text that you give it, and then how it returns this schema back to you. Because basically, when you're using this mode, um, what you get in return is a JSON with each of your arguments, and then the data that corresponds to those arguments from the text that was given. Okay, so let's get to another example here. This is kind of a hypothetical email that you could receive, and it's basically describing a CAN network. You see it says, well, I'll play it, and then I think I can read it later. Basically, I just copy and paste this email into the TRS tool. So first, yes, so I do this, send message. I'm just going to pause it. Let's just analyze what I'm writing here. So I'm saying I need 2 CAN channels. Channel 0 is main controls. Channel 1 is aux controls. Channel 0 has 3 ECUs. Channel 1 has 1 ECU. Channel 0 has a baud rate of 500 kilobits per second. Channel 1 has a baud rate of 250 kilobits per second. ECUs on channel 0 have addresses 100, 101, and 105. They represent engine temperature, pressure A, and pressure B, respectively. ECU on channel 1 has address 200, and it represents washer fluid level. All ECUs on channel 0 have a watchdog timeout of 100 or 1,000 milliseconds. So I send that. It communicates with the API, and it generates. I basically set up a multi-dimensional function call that has a list of CAN networks, and each of those CAN networks has a ECU on it, and then each one of those ECUs can contain more information. So this was kind of a test of how good this function calling actually is, and how reliable it is, and it turns out to be pretty good. So as you can see here, the first network 0, 500 kilobits per second, that's exactly what we said. The engine temperature has a preferred address of 100 and a 1,000 millisecond timeout. Pressure A, preferred address is 101, and the watchdog time is again 1,000 milliseconds, and then pressure B is 105 address and 1,000 millisecond timeout. Aux controls is on network 1, which is correct, and 250 kilobits per second. Again, for this washer fluid level, it gets the preferred address correct. And this time, even though I didn't specify it has a watchdog time of 1,000 milliseconds, it decided to put that in. So I just do another example here where I change, I just specify I don't want the, I want the engine temperature to actually have a watchdog timeout of 200 milliseconds, and I don't want the washer fluid to have a watchdog enabled. So yeah, I'm typing here aux controls have watchdog disabled. So then I send that. And again, we'll just quickly go through the CAN channel, the CAN network that it created, and you'll see that it takes those new data and it correctly implements them. So you see the engine temperatures, watchdog timeout is changed to 200 milliseconds. Everything else stays the same on that CAN network. And yeah, this is still correct. And then in this case, the watchdog timeout is disabled on the washer fluid level. And that's exactly what we wanted. So you can see that it can pretty accurately take a convoluted paragraph and given the function schema that I provided it correctly infers the meanings for each of the arguments in my script that generates these. Okay, so here's another example. Taking informal language and creating a well-documented, this time it's an enumeration. So, and this can be done with function blocks and structs as well. We'll play this. So I'm just telling it I want this enumeration to be created in the DUTs folder. So create an enum for mixer states. So yes, I've created the enumeration, and now I'm going to populate it. So again, I have to focus on the enumeration. I'm using informal language, but it still gets the right one. So then here, I say populate the enum with the states described here. And I'm also saying keep the line length below 80. It doesn't always follow that, but it kind of helps it not create code that's extremely long on one line. So the mixing device has multiple states. The first state is off. When in off state, it is recommended to not apply any PWM to the coils. The second state is idle. The mixing device must idle until temperature has reached 90 degrees Celsius. The third state is called active. In this state, the mixing device is responsive. Note that if the mixing device temperature exceeds 140 and the oil pressure exceeds 150 kilopascals, the mixing device must enter its regen state. And just below that, I describe the regen state, and it's basically, I say when it's in the regen state, the mixer is going to be torque limited to 50% of its maximum torque. So given that big informal block of text, you're going to see that it does a good job of creating a well-structured, well-documented enumeration. So we got the API reply, and as you can see here, it has our 4 states: off, idle, active, and regen. And it has comments beside each one that match up to what I've described in the informal block of text. So I think this type of templating is very powerful. And the reason I think that is because when you're going through a project like this, there's so many conversations that you have with customers and between other programmers, and there's hardware documentation. Basically, so much has already been communicated that why not leverage all these things instead of having to rewrite everything so many times. Let's leverage these design docs that we've made with the customer, and let's template a large portion of the project and just make it easier for ourselves. Okay, so here's another example. In this case, I have a function block where in the declaration area, I've defined its different inputs and outputs and the internal variables that it's going to be using. And then in the implementation area, I've given it just some comments of basically what I want to happen or what I want to be coded. So first off, I'm just saying if the state is not running or in regen, set the PWM set point to 0. Calculate the target current for the duty current. If state is in regen, then activate float mode during duty current calculation. Use PID to calculate the PWM output, and then manage error handling for the error output. So let's see how it does this. So again, I'm just focusing on this function block so the LLM knows what I'm talking about. And then I'm going to say complete the code. So it's doing its API communication. And it should come back to us. So it takes a bit longer because it's generating a lot of text. Okay, here we go. So it says successfully completed the code. So let's take a look at it. So first thing, it takes the first point and it successfully implements that. So if the state is not running and it's not in regen, then the set point equals 0. I'm just going to back that up a tiny bit. Oops, sorry. Just so I can go over this. Else, do the duty current transformation. You see it. I have the float mode equal to state equals regen. So basically, this is correctly implementing what I asked it to. And it says, so I've said, if state is in regen, then activate the float mode during the duty current calculation. And it does exactly that. The target milliamps is set to the PID set point, and the error is forwarded to the error, which may not be the best way to do it. But I would say overall, I'm 90% satisfied with the code that it's created in that section. So down below, it starts going to the the PID. And here, there's a couple things that I would say aren't perfect, but again, it does a good job and it saves a lot of typing. So it sets your PID constants to the correct PID inputs. It sets your output to your PWM, and something I'm not crazy about is that the set point is set to the PID set point itself. It's kind of looping back. I did compile this and it does work, although that's probably something that I would edit. But again, it's still very helpful. And you can see at the bottom with the error management, it says if a duty transformation error or a PID overflow, then set the error to true, else the error is false. So pretty good. Definitely good for the workflow. I would kind of liken this to GitHub Copilot, where it's going to suggest based on the context of your project, it's going to suggest a few things, and a lot of the time it gets it right. And if it doesn't get it right, it's still a huge help and saves a lot of typing. So this test was definitely a success for me. The last example I'm going to go over here is using the compiler output to correct code. So I've done some very simple tests with this, like forgetting to use an end if, and then trying to compile and seeing if the LLM can use the output from the compiler to correct its code, and it definitely can. So I've also given it a kind of a weird example where I set one of the outputs, I do some syntax that's completely incorrect. It doesn't make any sense. And the compiler responds with limits active is no input of PID. So when I kind of orchestrate this information correctly and give it to the LLM, this is what it replied with. And I thought this was kind of interesting because not only did it fix the problem with setting limits active equal to error, but it maintains the overall spirit of this function block, and it continues to manage the error handling. So you see it moves this PID limits active to the bottom block where it says if error or PID limits active, then PWM equals 0. So it's pretty good. And this is kind of just the beginning with all this iterative correction. It's going to be really interesting to see what we can do with this. So just kind of wrapping things up here. What has been demonstrated with these LLMs? Well, we know it can create POUs and DUTs. It can instantiate and call POUs. It can template communication networks, and it can write and edit code, as well as correct code based on compiler and text feedback. Something that wasn't shown here is it can also create unit tests. So because it can create its structures, and then you can get these LLMs to kind of follow a testing framework. So with this compiler feedback and unit test feedback, it's going to be really interesting to see how it can correct itself, and then how close to perfect you can get with these LLMs. So some other things that the LLMs succeed at are editing code, refactoring, adding comments, explaining code, processing data and changing it to your desired format. If you have pre-existing scripts that require a certain CSV format, the LLMs can take a different format and do a good job at converting it to how you need it. What they don't succeed at is extremely specific tasks that are better left for scripting. So if you get too micromanagey with these LLMs, it just doesn't work, because remember, these LLMs are predicting the next token, and if what you want is very specific and it's never seen anything like that, it's going to have a harder time to predict the next token and make any sense. Another thing it doesn't really succeed at is very large convoluted tasks. So really quickly here, I'm just basically, how does TRS envision LLM usage in CODESYS for the present? So for the present, we think that for your main use cases, you can basically design a template form to be filled out by customers or engineers. And an optimistic estimate would be breaking down this template form into however many smaller tasks that the LLM can successfully do. I estimate that it can template between 50 and 80% of your project. But again, it's not going to be fully automated, because of course we're dealing with CODESYS here, and most people who are using CODESYS are interacting with real life machines that can damage property or human life. So you're always going to have to verify this. And if the goal of using these LLMs with these benefits here is it's supposed to automate the monotonous aspects of programming so that you can have better project architecture, more testing and more thorough documentation. So it's supposed to make it easier for you so you can focus on making more stable and safe applications. Again, there's other benefits like faster turnaround for agile development and a more uniform code base with emphasis on good documentation. Those are some other benefits. For the future, there's the possibilities of these recurring LLMs checking compiler feedback and checking unit test feedback that you can probably make an agent to template a lot of the project for you. It opens up doors for voice interaction with CODESYS, and as well, this would be great to see in the future, rapid development for visualizations, maybe with CODESYS Go or native CODESYS XML for your visualizations. But just talking with customers, one of the most time-consuming things is going back and forth about UI development. Leveraging these LLMs in the UI development could really speed that up, I think. And lastly, some options. New LLMs are being released every day, including ones that fit on single local GPUs. And there's so much more experimentation going on with fine-tuning these models that it really does seem like this has a lot of potential on top of the value that it's currently adding. I think you can make a lot of interesting systems with incorporating these LLMs. Okay, so thank you very much for staying with me there.